Actually, multipass weld bead. This is one of the sample of multipass welding bead. It's very difficult to figure out each welding bead. And the next is issue of the blind spot. This is a sample of overlap bead. The blind spot part cannot be detected by sensor. And the next one is only category A for multiple imperfections. And the last one is also one of the difficult issue. So especially our GIS certification scheme has a very complex criterion system. This is a sample of the criteria table. You can see the GIS and comparing AWS and ISO. AWS and ISO is very simple at their criteria, but GIS is kind of very complex for determining okay or not good. So if we implement this method, such automation, into our GIS way, Japan way, the automated system have to cope very complex process to determine okay or not. So the GIS World Certification Scheme annually weld about 120 weld test plate, and bend test specimen is more than twice. Due to Japanese industry demand, more than 70% examiner takes 9 or 19 millimeter thickness plate test with multipass weld. So such kind of automated sensor should cope such a multipass welding bead. The following is a conclusion of the feasibility study as of present. So we do not see any possibility as of now at the visual test. Maybe in bend test. This example of a bend test specimen, very flat and simple. So this may have some possibility to make this happen. So we had the very first trial test with the drill hole test plate with drill hole, 0.3 millimeter drill hole with oversize and lower size, and 3 millimeter drill hole with oversize and the left side. And this is the picture of the test plate. You can see the 3 millimeter drill hole, but you cannot see any 0.3 millimeter drill hole. And this was the result. For detection of 0.3 millimeter hole failed completely. And the 3 millimeter drill hole, they could detect it, but not enough. So consideration of cause is a major cause of undermatch of pore size and resolution of sensor. This is the one sample of 0.3 millimeter drill hole, and laser sensor could detect it. Only 4 points of cloud data for 0.3 millimeter drill hole. For the 3 millimeter drill hole, the sensor could detect it very well, entire drill hole shape. But at the sharp edge, the laser sensor cannot detect precisely. That's why we cannot use RSIs. As a last, this is the current situation. If we can change our rule, it may be easier, but no way. And implementation to if we can use a laboratory class, like submicron resolution, it's very expensive. So no way. So if we pursue much higher resolution way with present industrial commodity product, we may have some possibility. And another way is to give up automation. So semi-automatic, so share the human and the machine, but still 0.3 millimeter detections have some difficulty. On the other hand, we may be able to find out another device in the industry, so we may be able to get to the goal. The other hand, we still remaining the way to image recognition method, so we may be able to make some improvement with this method. So these remaining homework we have. So I think goal is very far from now, but we may be able to make big improvement. That's all I have.
Thank you so much for your presentations. Và ngay bây giờ xin được kính mời Ms. Dasan Teses Krasbada đến từ Hội hàn và Khoa học Vật liệu Mông Cổ Mongolian Material Science and Welding Society với chủ đề Power Plant Stage Yard Stock Company Reconstruction of High Pressure Pipelines, tái thiết đường ống áp suất cao tại công ty cổ phần nhà máy điện. Please warmly welcome.
Thank you. Hello, good morning. I am so happy to stand in this stage. On behalf of Mongolian Material Science and Welding Society, I am a member, Tsagan Tsitsik. It's so hard to call my name, I understand. Today my topic is Thermal Power Plant 4, State Joint Stock Company, Reconstruction of High Pressure Pipelines. And firstly, I want to talk about in our region, in our country, special things. And our country is located in the center of Asia, and two big countries, boundary in China and Russia. And we have 4 seasons: spring, winter, fall, summer. Mongolia has a continental climate with a long, harsh winter and short summers. So we really need thermal power plant heating and energy sector, really important. Over the 8 months, and we so cold, and heating system is supplying for really important in every household and whole city. And before a slide mentioned about in one of the biggest, so coldest year, 2000 to 2001 is minus 40 degrees, so cold. And please previous, and how can I move this? Yes, thank you. And so average highs ranged of minus 33 to in winter, and summertime 25 to 35. And our Mongolian population now currently in 3.6 million people living, and capital city of Ulaanbaatar now, you see in 4 years, and 1.6 to 1.7 million people living, and population is increasing in the city, and Ulaanbaatar population average annual growth rate is around 1.7 to 2.3. And growing is manually driven by internal migration and natural increase birth. And also some countryside people is mostly moving to in a city, and there is so much customers increasing in supplying energy sector. The increasing concentration of population in the city is putting more pressure on the infrastructure, housing, and social service, and also in our sector. Yesterday, some of in our members, AWF members and another Vietnam people is asking about how's your country, how's the Ulaanbaatar, and so I'm going to show you a short video in Ulaanbaatar. No music, it's okay. It's Genghis Khan. It's in our government places. And some of our members visited in the last year in Mongolia. You walk it and take a picture, right? And there is, you see there's a big apartment, it's construction and mining field is developing, and so energy and that sector is really important. So there is real construction is doing connection with the welding. And also some people asking about which month is very good to travel, and we in our Mongolian team suggested to in July and August is so beautiful, and summer and short summer is so July and August so beautiful to travel in Mongolia. There is a Gir district. There is some of them no supply the heating thermal system, and so their own household made their own fire and heating, and just only electricity is come. And some of them they actually is organized in a heating system by energy and electricity, but price and every household and some costs so increasing, and they depend on own economy, and mostly they made by manually is firing. Previous, sorry. There is Ulaanbaatar's and thermal power plant is looking, and the first line is three kind of two, and heating and electricity and manufacturing and supplying to the customers. And the second line is just only in a Gir district that actually, in your before slide I mentioned about Mongolian population is growing, and so we are also growing by heating thermal system. And that's second line is Gir district around, and also supplying the heating system. That's going to decrease the air pollution also. Thermal power plant is for, and in our engineering team is working on their pipeline welding work and reconstruction works. And thermal power plant actually is made by foundation ceremony started 1987, and also started to 1983, and the first unit capacity of 80 megawatt was commissioned. In 1984, 2 units totaling 180 megawatt. In 1985, 3 units totaling 280 megawatt. 1986, and 4 units totaling 380 megawatt. In 1995, units totaling 460 megawatt, and in 1991, 6 units totaling 540 megawatt are installed. That's actually always improving and always reconstruction and did it. And 2007, and capacity of unit TF5 has increased by 20 megawatt. In 2015, turbo generator number 7 was put under operation, and 2019 to 2020, and turbo generator number 1 to 4 were upgraded, resulting in a total installed capacity of 772 megawatt electric power and heating gigawatt of thermal energy and 1,586. And it's in our thermal power plant and manufactured and connected with the Russian technology. And the energy, actually, thermal power plant is the most of the #1 biggest and the power plant in Mongolia. For example, energy consumption and supplying and 59% is supplying the energy, and Mongolia in other is 41. And there is a heating consumption as thermal power plant is actually 55%, and so it's the biggest one. You see then outside of the thermal power plant installer capacity I mentioned before, and I want to show that peak. And there is a boiler and a number 128 and manufactured here in capacity and also started to use it here. And every year, and so peak loading is so much, and so every year we, our engineers trying to reconstruction and improving. It's really important. Engineers is still working on fixing it. It's turbine, and turbine also have you see the turbine model also in the first line and second line in manufacturing years and capacity, and they started using years as you see. And so of course it's last 40 years, over the 40 years, and we have to improving and reconstruction. That's really important for us. Firstly, in our engineers worked on this pipeline inspection. Defects are cracking it's so much, and so next page you're gonna see they have to work it there. And I'm going to show you in the purchasing pictures. And first, he is in our general engineer in Altasuk. And he is so managing everything and also working with the team. And he is so very best manager. And also you see that the two kind of structure. One is permitted standard. One is another and over the standards. It's you see that there is an beneath per lead per structure rated and 7 points. It's over the permitted standards. And so he's made this research. Compare that things. We are living in a time when Mongolia faces an urgent need to define a path towards rapid development and to implement large-scale industrial and infrastructure projects. It's clear that these developments are unimaginable without a reliable supply of fuel and energy. The energy demands of central energy system has been increasing year by year, and comparing electricity consumption 2020 with that of 2024, it has risen by 12.8%. You see then that lower that table, and for 5 years, and peak load increase, and that's related to the population also. And so, and also developing means in developing apartments and a population, everything is increasing. It's directly is connecting. And a welding procedure, the pipe ends and were beloaded at 15 angle and baking ring with the width of 30 millimeter and thickness of 3 millimeter was installed. The ring was tack welded at the 45 angle to prepare for welding. The root pass welding was performed using TL39 electrodes and 2.5 millimeter and manufactured by a leg company in the Russian Federation. That second line is pipe ends and were prepared according to the welding process specification, and the welding was carried out in the 6G position using the pat joint configuration. The welding was performed using TL39 and TMLDU electrodes. The reheating period to the welding was conducted at 300 cesium also. Heat and treatment. you're gonna see there's heating treatment procedure involved with a controlled heating rate of 0.1 per second up to 300 Celsius, followed by a gradual increase from 300 Celsius to 725 is over 3 hours. The pipeline was held at 725 for 2 hours, depending on the wall thickness. After that holding period, it was cooled down to 300 Celsius over a span of 3 hours and allowed to cool to ambient temperature under installation. Mechanical testing. You said there is a bow and picture and table and a welding seam pipeline with dimension and also sampling location too, and also hour just a little bit different, 12 hours and 6 hours. The strength and specific. Boiler stream collection chamber piping modernization. It's a action picture. Action picture is looking like an old version, and after that in the welding after it's changed. It's like in a piping modernization. Conclusion. As a result, a complete implementation of the project to extend the service life and upgrade the high-pressure pipeline of power plant for a state-of-the-art company, the technical reliability of plant operation for over 40 years since its commissioning has been fully ensured. This major modernization initiative stands as a model project, making significant contribution to the stable and sustainable development of Mongolian energy sector. Thank you for attention, and please, and if you have any detailed question, I'm going to connect within our engineers and give it to you, and so good detailed information give it to you. Thank you. Thank you very much. Have a good day.
Thank you so much for your presentations. Và ngay bây giờ xin được kính mời Mr. Ishikawa Takashi đến từ công ty Fanus Việt Nam với chủ đề Physical AI's Annual Account Welding Robot Technology Introductions, giới thiệu AI vật lý và công nghệ robot hàn hồ quang mới. Xin để trân trọng kính mời.
Good morning. My name is Ishikawa from Phanak, Vietnam. Thank you very much for giving the time to present today. I feel a little bit nervous speaking in my welding experts. Sorry. First, let me now introduce our company a little. Phanak is located at the foot of Mount Fuji in Japan. We provide a CNC system, some robots, some injection molding machine, wire cut machine, like that, for factory automation. In 2024, total shipment of industrial robots reached 1 million units. Our robots are most widely used by around the world. Now, I will move on the main parts of my presentation. Today, I would like to introduce our recent activity focused on physical AI and arc welding. I mainly explain the technology we exhibit at the IREX exhibition last year at the Tokyo Big Site. This slide shows we exhibit the recent IREX exhibition. Today I will explain about our open platform and physical AI and auto-pass generation and lightweight CRX in relation to arc welding. At first, I will explain platform and physical AI. Acceleration physical AI implementation through open platform support. Without physical presence, even advanced AI cannot operate in manufacturing. FANUC provides robots as a physical AI body, enable physical AI. We have 3 categories. Open platform, ROS2 support, and Python support for AI development. Robot can move with Python programming. And next, stream motion through 1 kilohertz high-speed external command input. I want to explain physical AI example through open platform support. By integrating sensing, AI decision making, and robot action to create an intelligent system that see, think, and acts like human. I'm sorry, no sound. Robot operates by generative AI. For example, like that, human speak some order to robots. Then generation AI make some programming with Python. AI recognize command from voice, support Japanese, English, Chinese, of course Vietnamese, and more. Or some text order, no problem. Then next, he said other order, but please change the cycle dice to 1, number 1. Robot can recognize other order. Every time generates Python programming. One time checking camera. Finally, dice change to 1. And next, AI robot that does not collide human. AI robot that does not collide human, AI robot recognize human with a camera. AI robot and AI robot recognize how to avoid contact in real time. AI robots return to the original path when human leave. And we have some other example, but dual control CRX with AI, and AI tracking, moving workpiece and tightening the bolt. And next, we will explain the arc welding contents for FANUC. This is a CRX all pass generation for arc welding. Auto pass generation of arc welding by a servo robots sensor to any kind of workpiece. At first, operator can teach with hand teach and some sensing position. And next, robot sensing the workpiece situation as with servo robot sensor. Data is like that. After that, it automatically generates the position of the robot. This accuracy is very good. And next, we will explain about the ultra lightweight CRX3. Operator can pick up this robot very easy. Weight is 11 kg, but he's not muscle. Using this CRX, portable collaborative robot, as this movie. The ultra lightweight CRX3 can be carried by one hand to welding location and fixed using magnet. The installation angle, such as a wall or ceiling mounted, and detected unnecessary parameter are set automatically. Then touch sensing or servo robot sensor enable automatic compensation for relative position to steel plates to be welded. Then this robot can move waving motion. Accuracy is enough. Very good. Finally, I will explain about the generation AI with welding application. This is the only example. There is always some gap between digital data and real welding. To solve this problem, we can combine AI with proven sensing technology, such as arc sensor or some vision systems. For example, operation installs a robot with hand carry at the work site. For example, a portable collaborative robot I explained. And next, AI automatically generated the welding path based on environment and workpiece data. But like I experienced generation AI. But this is not very designed yet. Then at first, finally, arc sensor adjusts the path in detail during the welding process. But we can achieve the welding motion automatically. I think like that. Thank you for my. That's all.
Thank you so much for your presentations. Và ngay bây giờ thì xin được mời toàn thể quý vị chúng ta sẽ cùng giải lao và dùng tiệc trà ở phía bên ngoài sảnh trong vòng 10 phút. Và thời gian tiếp tục phiên thứ hai sẽ bắt đầu vào lúc 11 giờ 10. Ladies and gentlemen, we would like to invite all of you to enjoy a 10 minutes coffee break and live refreshment outside the hall. The second session will resume at 11:10 a.m. Ladies and gentlemen, and now we would like to invite all of you to return to the hall for our next session. Thank you very much. Ladies and gentlemen, and now we would like to invite all of you to return to the hall for our next session. Thank you very much. Và ngay sau đây xin kính mời ông Ngô Văn Trọng đến từ công ty Bảo Chi Company với chủ đề POP Technology for Hard Facing Gray Plate Production, công nghệ POP trong sản xuất tấm mài mòn bề mặt cứng. Xin được trân trọng kính mời.
Okay, good morning. Good morning, everybody. I hope you already got a little bit more energy after break. So we restart the work. I was invited to introduce some works that I and my team have been doing. This is for almost 6 years from now on. And we call the POP technology. Is using for producing our wear plate in our factory in Hanoi. A little bit about myself. My background is I'm from Hanoi University of Technology, Welding Engineering. And since almost 20 years, I have been working for overlay welding, repair, maintenance weldings, and I set up the company, my own company, in 2014. Up to now, I got about 12 years working in the BCC, and the BCC we are a professional producer of wear plate, of wear part. And we are also doing the refurbishment service for some heavy industry where that the equipment operating in very high wear factors, like cement, like power, like mining. And we are spend a lot of our resources to do research and development for the products. Very simple understanding what we are doing and why our customer need from our product and service, and what we can improve the customer from side. You see here, we have from outside, we have the cement, we have power, we have oil and gas, steel making, mining. All of industry, the equipment running in very high factors. It could be the wear factors in those industries, including abrasion, or erosion, corrosion, heat, impact, and cavitation. It means that these factors is the reason why customers need the wear-resistant products. So the next one will be replace, will be repair and refurbish. This is the way how we deliver our solution to the customer. And we have overlay, a power overlay. We have PTA, laser, spraying, manual electrodes, and flux core wire. Meaning that it is the processes that we have been using for making the products. And the product, we had the powder, we had the electrodes, and we had plate and wire. That is form of the product. That is from outside. Look into the BCC, meaning that we have inside customer that we define our core business is how we can make the powder formulation. So we define powder formulation as our core business, core technology. The main product that we have been produced since 2014, that the wear plate. There are two layers, the hard facing and the base materials. This we have been using the plate, the hard facing wear plate produce a POP. POP standing for powder overlay process. This is for a wear resistant. This is a very simple definition of our main product, D-plate. The application could be used for many industries, as I mentioned, cement, steel, mining, and power. That's the main industry that we are supplying, and the product also exporting to some industry in some country like Belgium. We have been exporting to USA. We have been exporting to Indonesia as well. So at the beginning, in 2014, we used flux core wire to produce the plate. But at that time, we had some difficulty how to change. When we come to different customer, different industry, the customer require different, let's say, the working environment. It meaning that it has different wear factors. So we had to come back to how to find a suitable product. Then the original idea come from, at that time, 6 years ago, we have the idea that as the welding people, we have electrodes, we have core wire. The structure of this, they had a core inside the mild steel, and outside also the mild steel. This is outside the cover, we have flux and some different alloys, different elements. And also here, inside the core wire, they have a different element. Depending on the application, the element could be different. The formulation of that also different. So that's the reason why we come up with the idea. We separate it. We supply independently, supplying to the welding pool using the powder and the solid wire. Why? Why we do that? Because as I mentioned, when it came to the customer, different industry, they had a different requirement. So we had to come back to change the formulation of the powder and the ratio between the powder and the mild steel. So if we do it as a normal way, we had to come back to the electrode or the wire. So we had mixed powder and we had solid wire. That's the idea. But the problem when we come with that, it's very difficult to control how much of the powder and how much of the solid wire we supply to a welding pool. So we had to design a system how to control it perfectly. This is a very definite. You see here, this system was designed at the 6 years ago, and we had here the container supplying the powder to the welding pool. Here also supplying to the welding pool. Here the steam plate and the wire feeding. So we had to control how much of wire we're feeding to by controlling the wire feeding motors, wire feeding speeds. And also we had here they had a motor here, how to control the feeding speed of the powder into the welding pool. So this is something like submerged arc. Many people say it's submerged arc. It looks like submerged arc, but no. The process looks like the submerged arc, but it is somehow is in the middle between submerged arc and open arc, because there are no slag here. When after welding, there are no slag creating on the surface. So we call the POP because then I remember one time when I was in one seminar in Hanoi University, I presented to the one a presentation of a representative of AWS. He said that he's not able to qualify this process because there are no standard for this process. So we define it as a POP. So as I mentioned, the system is very important, how to control it. It had to control the acceleration, the movement, or the track movement of the welding traveling speeds, oscillating, the range of oscillation and the point in between here, all the traveling. And very important that, as I mentioned, we had to control how much powder we feed into the welding to make sure that we had to control how much of thickness of the welding layers we had to deposit on the surface. And also the specification of the overlay welding, the hard facing layer need to be controlled. How much of alloying we put into, how much of chromium, how much of niobium. It's many different kind of alloy we put into the powder to make sure that it can be against the wear factor. For example, if we come to mining, the normal temperature, we just have some basic chromium, basic carbide like chromium carbide. But if we come to some industry like power or steel making, so it not only abrasion, it also had a corrosion, also had heat as well. So we had to add into the something niobium or some other factor, depends on the requirement. So it's very flexible how we can create the formulation of the powder. So we have the formulation. Then this system had to control all the factors to make sure that we have achieved the specification of the hard facing layer. Okay, sorry. Then we tested all of product need to be tested before had the official specification. And this is standard how to measure the wear resistance. And we package all of this into the one package to send it to offer to customer that anyone who are doing the steel work fabrication could become the wear plate producers in local. So we have one customer and one partner in Egypt. They are having our technology and producing the wear plate in the Egypt. I want a short video about how we can connect between our plate and phở. I'm sure that you had tried phở in Vietnam, and it's very specialty. I'll give you 1 minute more about, I will explain what is the connection between the plate and phở. Because I'm sure that you had tried phở in Vietnam. Phở in Vietnam has some different point between soup noodle of Vietnam and some Asia country. Because in Vietnam, if you go to phở with beef or phở with chicken, the soup is different. But if you go to other country, they had a different meat or different kind of noodle, but you had one soup, right? So, in Vietnam, special of Vietnam, we're the pseudo between soup and the meat. So, converting to the plate, we had a different formulation of the powder, which is suitable for different kind of industry, different kind of wear factors. So that is the connection between our plate and phở. So thank you very much.
Thank you for your presentations. Và ngay bây giờ xin được kính mời ông Trần Văn An đến từ Công ty Cổ phần Nam Vượng với chủ đề resistance spot welding machine, máy hàn điểm điện trở. Xin được trân trọng kính mời ạ.
Alo. One, two, three. Distinguished organizing community, respect expert and honorable conference participants. My name is Chantit Kha, and today I represent Mr. Chavanan, the director and author of the project. Uh, today is my great honors to participate and present at 19 Asia Welding Technology and Application Forum. And this my company always focus on the welding machine and cutting machine. We always provide welding solution for construction company, and this is some our achievement and application. And in the framework of this presentation, I would like to share the research and development process about the MKFS 3001 automatic resistant welding solution. And in 2023, during participation in a nuclear power plant project in Egypt, Dazum construction group encounter a high specialty technological requirement. The task is well 19 by 19 by 20 millimeter flanger onto the end of the high strength deformed steel bar with diameter the 25 and the 32, while ensuring the minimum tensile strength of 500 Newton per millimeter square. This is a significant technical challenge because the material possess high mechanical strength, make hurt control extremely difficult, while absolutely no defeat were permit the well choice. In the practice, conventional welding method fail to satisfy the required mechanical properties as well as the weld stability under the condition. And faced with this challenge, Lam Company
we collaborate with Daizung group to conduct research and develop a solution within extremely urgent framework time. This only 15 days. Based on the analysis of the actual requirement, we select a approach based on the principle of resistant offset welding, inherits and further development from the technological platform of RSN7 tub welding machine. And during the development process, the research team conduct a detailed analysis of technical requirement to determine the appropriate hurting mechanism for high strength steel material, while accurating optimizing critical parameters such as welding current and welding time. And we have some results achievement, testing and practical application research demonstrate that the solution achieves performance beyond the expectation. The research team will exhibit uniform penetration with no crack, while thermal deformation were minimized. The tensile strength reached up to 550 MPa, exceeding the initial technical requirement. And in particular, the welding time will reduce is only 5 to 7 seconds per weld, and conventional metal require approximately 4 to 6 minutes. The entry system fully certified or accepted standard of the international project, affirming the feasibility and reliability of Vietnamese technology. And the application of MKFS 3001 resistant welding machine deliver a clear manufacturing benefits and reduce welding time, improve productivity and operational efficiency, while the lower energy consumption. In practical, because low filler material are used, the welding process contribute to emission reduction and align with green manufacturing orientation. And the successful of the MKFS 3001 is a clear testament to the domestic capability in research and technological mastery, while also opening a new approach for high strength weld solution in sectors such as energy, infrastructure, and heavy industry. It also serves an important foundation for the continued development of advanced welding technology associated with automation and digital transformation in the future. Thank you to the organized committee and all participants for your attention. I'm looking forward to receive comment and discuss from expert. Yeah, thank you.
Thank you very much for your presentations.
And anyone have any question? Yeah.
Thank you for your presentation. I have a question about your technical challenge you mentioned in your presentation. What is the main reason of why you choosing this resistance sports welding instead of conventional arc welding process such as gas metal or flux core arc welding? And besides this, do you think since this weld process achieve both strength with high strength with a very short welding cycle? You mentioned that is 5 to 7 seconds per cycle. Do you think this will be widely adopted in a Vietnam special project or widely adopted? Thank you.
Okay. Yeah. Thank you for your question. You can see the productivity of our machine. Like the welding time reduced from the 4 to 6 minutes to 5 5 to 7 seconds, and we uh, we apply this we just apply this machine in Daizong project, and they in a few years ago they buy a 20 machine from our company, and they export this machine directly to the Russia company. We show 10 resistant welding machine for Russia company, and I hope in the future I can sell this directly to the foreign company. Yeah, thank you.
Thank you so much for your presentations. Và ngay bây giờ xin được kính mời ông Hoàng Bá Khoa đến từ công ty cơ khí Hồng Ký với chủ đề Optimization Approach TIG and MIG Welding Parameters, tối ưu hóa thông số hàn TIG và MIG dung. Xin được trân trọng kính mời ạ.
Good morning, everyone. My name is Hoàng Bá Khoa, and I am Welding Solution Expert from Hồng Ký Manufacturing and Trading Company Limited, Vietnam. Today, I will present my research paper. First, let me really introduce the background of this study. My work focused on developing electrical welding solutions to improve productivity and weld quality in electrical environment. It also reflects Hồng Ký commitment to supporting our customer in solving welding quality challenges. Now, let's move the research background. In high-pitch and carbon manufacturing, welding quality is critical factor that directly affect structural integrity, safety, and overall reliability. Based on this instruction content, the main problem can be identified as follows. This study evaluates homogeneous weld quality in Q355 steel and 6061T6 aluminum, key material for high-pitch structure. The experimental setup consists of Hồng Ký thick and MIG welding equipment, along with fish parameter under control condition. To address this problem, we apply the design of experimental method to systematically study the welding parameter. DOE allows us to evaluate multiple parameters simultaneously and understand their interaction. Yes. Based on the experimental design, a second-order decision model was developed to describe the relationship between welding parameter and weld quality. Yeah. After welding, the sample was subject to mechanical testing, including tensile testing and bench testing to evaluate weld quality. This slide presents experiment research and repair of specimen for evaluation. After welding, the sample was cut and prepared for further testing and analysis. This slide shows evaluation of the heat at first zone. The head intestine and continuous long weld profile, indicating uniform heat distribution and no animal microstructure feature. This slide presents the bench test result. At the optimized welding parameter, the sample was testing weld activity and weld integrity under bending conditions. As shown here, the query zone mentioned in integrity without failures during the bend test. This slide presents the tensile result of the weld zone. As shown here, the red occurs outside the weld zone, which indicates that the weld is stronger than the base metal. The interaction between burn current, duty cycle, and background current is equated by fixing one parameter at its optimized values. Based on evaluation result of Q355 steel weld using Homkey 350 RS Pro. While one parameter keeps constant, the variation of other two parameters is analyzed in relation to sidewall penetration. As shown here, the red bar survey how their interaction affects the sidewall. The approach allows us to identify optimized region and confirm important parameter interaction. The interaction between PP30, background current, and balance is evaluated by fixing one parameter at its optimized values based on the result of 6061 T6 aluminum weld yielding Homkey 350 RS Pro. The variation of the other two parameters analysis in relation to sidewall penetration. The interaction between weld current volume and ductility is by fixing one parameter is optimized value. By on result of 6061 T6 aluminum weld use Homkey mixed to 70D. The variation of other two parameters is analyzed in relation to sidewall penetration. Thank you very much.
Vâng, xin được cảm ơn phần báo cáo và chia sẻ của ông Hoàng Bá Khoa. Và tiếp ngay sau đây xin được trân trọng kính mời ông Vũ Dương đến từ Đại học Duy Tân với bài trình bày Welding Technology for Joining the Bottom Head and Virtual Shell ở VVER Reactor in Vietnam. Công nghệ hàn ghép nối đáy và vỏ lò phản ứng VVER tại Việt Nam. Xin trân trọng kính mời.
Good morning, every distinguished delegate on the workshop. I'm very happy to see you, and we'll change a short information about the winding technology for the reactor shell. I come from Dutan University, which is located in the middle of Vietnam, the city Da Nang. And now I am working for the Dutan University as a researcher. Okay. As you know, it is expected in Vietnam in the future, very near future, we will construct the first nuclear power plant in middle of Vietnam. That is why we focusing on the knowledge and experience for the winding technology to join the bottom heat and vessel shell of reactor. The main focus in my presentation is to use artificial intelligence to predict the optimized parameter in winding process and on related procedure. Here we can see the machining and fabrication stage of the reactor pressure vessel lower heat, and here control the circumferential winding process for joining the reactor pressure vessel lower heat to cylindrical shell. And we recommended the consumable and method for joining a component. Especially here, summary of advances winding technologies and their applicability for the reactor lower heat shell joint. The base material, as presented, as you can see in the slide, is SHSN01 alloy. And, sorry. Here, winding procedure design. The main step. The first step, root pass, we are use GTAO. And the next two filling pass, we are recommended SAW for very narrow gap to join the heat and circumference component of reactor shell. And finally, cap pass. We can use GMAW or SMAW. Here, some recommended winding parameter, including preheat, root winding, filling, capping, and post heat processing after winding. As I introduced in the beginning of my presentation, we are using the artificial intelligence forward for predicting the optimized map of winding heat input, especially where we can choose this region, this area, winding speed and heat input to have the best structure of winding joint after procedure. About the microstructure, we also use the post-wind microstructure analysis and mechanical property. In the final result, AI-assisted analysis of aggregated literature data predict about from 25 to 65% reduction in residual stresses following post-winding processing. And circumference distortion for thick section joint is expected to remain below approximately 3 millimeters. And we are also recommended some qualification for industrial application. Finally, discussion, as you can see in the slide. And conclusion, the proposed winding procedure for improved alloy in bottom heat to shell circumferential joint incorporate a GTAW reed mechanized narrow gap, SAW for filling, and GMAW for capping with nickel-based buttering applied for dissimilar metal transition to super brittle phase formation. Thank you for your presentation.
Thank you so much. Và ngay bây giờ thì xin mời toàn thể quý vị chúng ta có thể đặt câu hỏi trong phiên thảo luận sáng nay ạ. Không biết là có quý vị nào có câu hỏi không ạ? Do you have any questions for? Okay. Và kính thưa toàn thể quý vị, phiên diễn đàn buổi sáng ngày hôm nay xin được phép kết thúc tại đây và chương trình buổi chiều sẽ bắt đầu vào lúc 13 giờ. Ngay bây giờ chúng tôi xin được trân trọng kính mời các quý vị diễn giả trong phiên buổi sáng, chúng ta sẽ cùng tiến lên sân khấu để chụp hình lưu niệm.
Chắc là xin phép là buổi chiều chúng ta sẽ chụp, bởi bây giờ đến giờ ăn trưa rồi. Đấy, cuối giờ chiều chúng ta sẽ tranh thủ chúng ta chụp sau. So now this is for lunch time. We have only 1 hour for lunch. Because we just part a half of the presentation today, so we have many presentation. Có câu hỏi à? Question? Question, okay. Okay, one more question for. Em cầm mic. So after question, we move to the lunch. The buffet place is similar yesterday lunch. Okay. So you have a question?
Yeah, I have a question. Can you bring up the slide?
Slide. Previous slide about his slide.
Yeah.
Okay.
Correct.
Hello.
Actually, my question is, you already have the submerged arc welding on
Yes.
the fill.
Yes.
Why don't you complete it with the same process until cap? Why must have another process to complete the welding?
Difficult consists of the dissimilar metals for welding. That is why we recommended this process cap pass GMAW.
Yeah, but when you're joining two metals together, your submerged arc should be compatible for both material, right?
Yes.
So why don't you just complete it with the sub-arc, the submerged arc? Why must still use the other process? Because the question there is, if you use that, it will make it slow, the productivity, because you have to switch with another process instead of just completed with the narrow gap submerged arc welding.
I understand.
Yeah.
Narrow gap is very specific technology. That is why we have to keep the speed for providing the quality, because some defect, for example, porosity can appear in the structure.
Yeah, that's for quality. I'm talking about the productivity as well, because after filling, you still need to do a capping, right? So why must still switch to another process while you can complete the welding using the sub-arc, submerged arc welding, SAW? So you don't need to do the, the GMAW and SMAW, because the sub-arc itself, you can complete the welding until cap.
Okay, I will consult with you, because everybody is waiting for the break time. Sorry. Yes, thank you.
Okay, thank you for the question. Maybe two of you will have a separate deeply discussed. So please. So now we can move for lunch. All Lakis, you can remain here, and the door is locked until 1 p.m. Okay? Yeah. Các diễn giả Việt Nam thì chúng ta cũng nghỉ giải lao, và 1 giờ chúng ta quay lại nhé. 1 giờ, đúng 1 giờ, hôm nay đúng. We try to on time 1 p.m. we restart. Okay. Bây giờ chú đi cùng ăn cùng mọi người luôn.